Hey, what's happening, guys? This is Hermsen with another algebra lesson. Now, if you recall back to my last video that I made, the problems that we had were factoring easy trinomials. I mean, if you want a refresher, go back to the last video. I'm going to run through it just really quick here. What you had is x squared plus some number with the x and some number, and you had to come up with what times what gave you that. I mean, if you want a refresher, I mean, it's on the last video. You can go back and check that out. This video is about factoring hard trinomials. Now, what we have here in this problem is 5x squared minus 17x plus 6. Now, the difference between an easy trinomial and a hard trinomial, the explanation is pretty basic. The main difference is that on the easy trinomials, there's never anything in front of that x to the second power right there. Now, on a problem like this, obviously there is. That's why I call them hard trinomials. When there's a number, or it's called a coefficient, is in front of x to the second power. Now, there's three different ways I'm going to show you to skin the cat on this one, so to speak. Different people like different ways, but my suggestion to you is watch all three of the ways, then decide which one you like the best and just stick with it, because it'll pretty much work every single time. Now, the first method I'm going to show you is known as a trial and error procedure. Now, this is the one out of the three that I'm probably least a fan of. I don't think it's real good, but a lot of teachers do teach it this way. So let's take a look. And this can be kind of aggravating, the trial and error method I'm about to show you. It's called the trial and error way. What we're going to do is kind of like on the problems in the previous video, we're going to create two parentheses right here. Then I think, okay, I've got an x to the second power. Well, what times what gives me x to the second power? Well, that's x times x, just like on the previous video. But the problem is there's that 5 right there. You know, x times x is x squared, but I don't have just x squared, I got 5x squared. Then I got to think, okay, so I got a 5 there. What times what gives me 5? Well, that's pretty much narrows it down. 1 times 5 is the only integer factors that multiply to 5. So 1 and 5. Now, for these numbers that go here, so I got 1x and 5x, these numbers that go here, well, I've got 6 right here at the end. I got to think up, okay, what are some factors of 6? Well, one of them's 1 and 6. You could also do 2 and 3. So let's try 1 and 6 first. So put 1 and put 6. Now I need signs. Now, if I have positive 6 up here, 1 times 6 is 6. The only way for it to be positive 6 is if the signs are the same. And since the 17 in the middle here, the middle term's negative, I'm guessing that both my signs are going to be negative. Okay, I pretty much know they're both going to be negative. Okay, now to check and see if this is right, we got to use the FOIL method. First, 1x times 5x, 5x squared. Outer 1x times negative 6 would be negative 6x. Inner, negative 1 times 5x would be negative 5x. Then last, negative 1 times negative 6 is plus 6. Put my like terms in the middle together. Negative 6x minus 5x is how you want to think of that as. But that's negative 11x, and that doesn't match up to what I started with. So I know that this answer here is not right. Now here's the aggravating part of this right here. And I'm going to erase this. We'll set up our two parentheses, and we know that that's got to be 1x and 5x. There's no other way to get 5. Now some of you are saying, well, I'll just put the 2 and the 3 right there. This is what's aggravating about this. Well, that could be, but you know, maybe it's the 6 that goes here and the 1 that goes here. I'm still going to use 6 and 1. I'm just going to put them in different places. They'll both again be minuses. So again, just switch them, flip the order that you wrote them in. Try to multiply it out, FOIL. 1x times 5x is 5x squared. 1x times negative 1 is negative 1x. Negative 6 times 5x, negative 30x. Negative 6 times negative 1 is plus 6. Like terms, you want to think of that as negative 1 minus 30. That's negative 31x. But that doesn't match up to what I started out with again. So I know that 1 and 6, there's no way it could be that. We got to try 2 and 3. Okay, so basically got to try it again. That's why it's called trial and error. Guess and check. Double parentheses, 1x, 5x. So we did 1 and 6. I mean, I tried to put 1 here, 6 here, then 6 here, 1 here. I know 1 and 6 aren't my two factors. So the only other way to get 6 is by 2 and 3. So put 2 and 3. Again, both should be negatives. They both have to be the same yet again because it's got to be positive 6. And since the 17 that I get in the middle is negative, these ought to both be negative. FOIL, 1x times 5x is 5x squared. 1x times negative 3 is negative 3x. Negative 2 times 5x is negative 10x. And negative 2 times negative 3 is positive 6. Like terms, negative 3x minus 10x is negative 13x. So, again, it doesn't match up. But I know there's pretty much only one other option. That's if I put the 3 here, I'll just erase it. You'll have to write it on your paper. 3 here, and then the 2 here. Let's trial that out, see if it works. 1x times 5x is 5x squared. 1x times negative 2 is going to give me negative 2x. Negative 3 times 5x is negative 15x. Negative 3 times negative 2 is plus 6. And finally, negative 2 minus 15 is negative 17x, which gives me a match to what I started with. Again, this, like on the last video, this is your answer right here. Okay, that's a trial and error method. You want my personal opinion of it. But, you know, go with that if you want to. Why I don't like it, as you can see, it took me 4 different times for me to finally get it right. And just imagine if that would have been like an 18 right there. I could have done 1 times 18, 2 times 9, 3 times 6. Then it's worse if that number's a negative, so then you need a positive and a negative, and you know you got to have them in the right place and so forth. Personally, that method, it's very not efficient time-wise, and I'm about to show you 2 more methods here that I think are very much superior to this, the trial and error method. Okay, the next factoring hard trinomials technique will be what's called the factor by grouping method. Okay, what I have here, just like on the last problem, I got trinomial, but x squared has a number in front of it. Okay, in factor by grouping, what I want to do, I have trinomial, that means 3 terms, that's why I call it a trinomial. What I want to do actually is take this and expand it, so instead of 3 terms, I actually have 4 terms. Okay, now, and how I'm going to get those 4 terms is I'm going to put a line through that 20x. I want it just a line. Now, don't just erase it or scratch it out, because I want to be able to see it. But I want to take that 20x and kind of chop it into 2 different terms. Now here's how I figure out what those 2 different terms are going to be. What I need to do, I'm going to set up a little graphic organizer, it's a T-chart. What I'm going to do is multiply the first and the third number, the 3 and the 7. You're going to do that every time. 3 times 7 is 21. So what I want to do is come up with 2 factors of 21, and I'm going to write this kind of up here. I'm running out of room a little bit. Now, the 7, like on the last video, that 7 is negative, so 2 factors is what I'm writing. You can't see it, I had to write small. 2 factors of 21 that, now if you remember on the last video, sometimes you added, sometimes you subtracted. If that number's a minus or is a negative, we subtract. And I'm going to try to get 20 right there. So that when I 2 factors of 21, so that when I subtract them, I get 20. Just like that. 2 factors that subtract to 20. 2 factors of 21 is what that means. Sorry about the writing, kind of got off further the ledge. Well, this isn't going to take long because it'd be 1 and 21. 1 times 21 is 21. Those are 2 factors. And when you subtract the 2, just subtract the biggest minus the smallest, you get 20, which is what you want. So my 2 things I'm going to split the 20 into are what I see on this T-chart right here. 1x and 21x. Now, I got to place the appropriate signs. Remember, I got to get 20x. I got to basically kind of work through it backwards. If 20x was positive, then the 21x, the bigger term, has to be positive as well. Okay? That's a positive, bigger term's got to be positive. Now, on the 1x, the only way to get 20x out of this, get these 2 to make 20x, is if that's a negative right there. That would have been positive, 1x plus 21x is 22x. But negative 1x plus 21x is 20x right there. Okay, so I got my 4 terms. I'll write it out here. Let's clean it up a little bit. 3x squared minus 1x plus 21x minus 7. Again, I just took the 20x and split it into 2 different terms. that when I combine them I would get 20x, but I want to split them into the two terms. Okay, now after you're to this point, getting down there is probably the hardest part. Now what you do is you want to set up a grouping of 3 parentheses, 2 parentheses there, or sorry, that didn't make any sense. 2 parentheses there, 2 more parentheses right below it, and then 2 more parentheses down here. Okay, I said grouping of 3 because there's going to be 3 lines of double parentheses right there. Okay, now it's called factor by grouping because what I'm going to do is group these terms. In the first parentheses, I'm going to group the 3x squared minus 1x, just in the order it's written. Then I'm going to group the 21x minus 7. The plus I just kind of forget about right there. Okay, if it's a minus you need to put the negative on it, but it's plus right there. Okay, so I grouped them. Now what I want is to factor out the greatest common factor in each one of these parentheses. So let's look at the first parentheses. 3x squared and 1x. Well, the greatest common factor of 3 and 1 is 1, and x squared and x, the greatest common factor is just x. Now, on this 21 and the 7, what's the greatest common factor of 21 and 7? Well, that would be 7, so put 7 and 7. Okay, you don't put an x on the bottom there because the 21 has an x, but the 7 doesn't, so you're not able to factor out x in that second parentheses. Okay? After that's done, what you want to do, and you kind of got to write small right here. I'll get up close so everybody can see it on the camera. The 1x that you factor out, you factor that to the outside. Now, just simply divide here, and that's what's in the parentheses. 3 divided by 1 is 3. X squared divided by x is x. 1 divided by 1 is 1, so minus 1. X's cancel on that one. Then, factor the 7 to the outside right there. Just put the 7 on the outside. And 21 divided by 7 is 3. 21x divided by 7 is 3x, sorry. Negative 7 divided by 1 is negative 1. Now, when you get to this point, you know if you're on the right track. If the 2 parentheses, as you can see, I got a 3x minus 1 here and a 3x minus 1 there. If these parentheses are exactly the same, you know you're doing it right. If they're different at all, if they got different numbers in the parentheses or different signs, then you know you did something wrong and you got to go back up here. Maybe you went wrong on one of these steps. Okay, and to finish out the factoring part of it, all you do is simply 3x minus 1, 3x minus 1. In the first parentheses, I like to drop down whatever's in each parentheses, which would be 3x minus 1. Okay, now in the other parentheses, you put your 2 outside terms right there, the 1x and the 7. So 1x, 7's positive, so that'll be plus 7. So 1x plus 7. Okay, now I need to go to my other board here because I want to FOIL this out and make sure, or actually I can probably do it right here. First, 3x times 1x is 3x squared. 3x times 7 is plus 21x. Negative 1 times 1x is negative 1x. Negative 1 times 7 is negative 7. Okay, put your like terms together. That's positive 21x minus 1x. It's going to be 20x right there. And it'll be positive, and that's just what we had up here to start the problem. So I know this right here, 3x minus 1 and 1x plus 7, that is my factorization. Okay, that is my answer to that problem right there. Okay. It's kind of a little bit long, the process right there, but it's not as bad as a trial and error procedure. You kind of pretty much use the same strategy every time. It's much superior to the first method. Actually, my favorite method is the one I'm just about to show you, the third and final one.